Hello. Yeah, I'm Ethan from Oak Ridge. I'm joined here today with some team members, Rick Moore and Brad Gibson. We'll be talking about data management practices on Orion and Air Force file systems. They've been very integral as a part of our current practices. So for an overview, we'll go over Orion, Air Force weather file systems, Lustre features we use, our experience with PFL, interesting scenarios we ran into with large numbers of small files and symlinks, our current purge policy and implementation for Orion, and how we handle performance tier usage. So these are our two HP Cray Close to Store E1000 systems. Well, I guess it's not quite two, there's actually three. There's Blizzard and Typhoon, which are the Air Force weather systems. And they're basically mini Orions. So Orion has about 600 petabytes of usable space. 10 petabytes is flash tier. We have 450 OSS nodes, 1,350 OST pools between those, and then 10 and 30 for the Air Force systems. So what we use, so yeah, we have tiered storage, we have flash pools, we have hard disk pools. We also use D&E. We're using D&E 1. So like on Orion, there's like 900 projects. Each project is assigned to an MDT. And then, yeah, project directories only reside on a single MDT. We also use DOM as a part of a PFL component, so we can leverage our flash tier a little bit more. And then here's our PFL. So Orion, you can see it's PFL. Air Force follows a very similar setup. It's just tweaked slightly different. And my understanding for where we got these thresholds for the different stripes and tiers is we looked at OLCF4s like Alpine and Summit. We looked at the users, we looked at the file distribution breakdown on Alpine and said, well, the workloads aren't really changing, the users aren't changing. That should be applicable for OLCF5. So the flash tier was spec'd accordingly. And then Brad did something similar with his AFW systems. Blizzard and Typhoon were very recently deployed. I think they've been in production for not even half a year now. So there's a lot of advantages for PFL, which is very nice. It's very versatile. So we actually have, my understanding is we have a set stripe wrapper. So whenever a user kicks off a job, in theory, like no matter what they want to do, and if they call the wrapper correctly, it'll just set their striping to adhere to the PFL. I guess the scenarios when that doesn't happen is if they're doing like a large single shared file sort of thing for their IO pattern. So yeah, we get more stripes across the capacity tier for large files. Small files end up on flash. It works basically for all users. Helps avoid filling up OSTs and saturating the flash tier, because that's a very large issue we had before that. Users, either intentionally or unintentionally, would really like to just use the flash tier, which is understandable, but kind of creates a headache for us. Yeah, and so I don't really know that. This is titled as disadvantages. I don't know if there's really disadvantages to PFL. I guess maybe, sort of. There's stuff that slips through the cracks. I don't really know that that's PFL's fault, but we've noticed that there's certain IO libraries. We've seen it with some MPI IO libraries where even if the user uses the set stripe wrapper, it'll just disregard PFL. And then you get called because your performance tier usage jumped 10% overnight and you're running out of flash space. So that can still happen. And then determining if a file is misstriped is a little bit more tedious because we have to look at files the user has, get candidate files we think could be misstriped, check the directory striping, check the file striping, usually hash it, compare hashes, compare the number of components or the layout it has, and it's very time consuming. But generally speaking, PFL works and prevents us from having to do a lot of that. Unfortunately, something that Brad ran into earlier this year, he had Blizzard and Typhoon. They're freshly formatted. I think they're in production for less than 2 months. And he gets called, and he calls me, and he's like, I'm out of space. And I was like, what do you mean you're out of space? You just deployed this file system. And he's like, well, my OST usage is 20%, but my MDT is at 98%. And it's Air Force weather, so we have some Interestingly enough, it's not like a classified system, but there's some very strict uptime requirements. So like if a user is doing something bad, like we can't just kill a job. So then Brad started like rapidly like trying to restripe data, migrate stuff off, but eventually like digging into it, and this was over holiday break. Brad didn't really get a break. It was like 2 weeks digging into this. We found out that there was a new workload that the users didn't tell any of us about. There was an error where they decided to create like, yeah, so his one MDT had like 1 billion files on it. 600 million files were just symlinks to nothing. So it burned through like a ton of inode space. And then there were some other like issues with small files and then having multiple like PFL extended attributes. So like inodes were just very large. So there was no files on the file system, but it chewed through a ton of inode space. And he talked to the users and they're like, oh yeah, we won't do that. So, you know, it was an easy fix, but a lot of times, I'm sure as you guys feel, we have to respond to stuff quickly and kind of just have to deal with what happens on the file system. There's some other ZFS tunables that kind of helped with this. And yeah, this can be amplified in DNE1 configurations because a project is on AMDT. So we're definitely looking to evaluate DNE3 very soon here. I think it would give us some more safety for when stuff like this happens. Take some pressure off of us when we get called to for runaway users. And yeah, so I inherited Orion from Jesse Hanley, who inherited it from Dustin. And so when I came and I started working on Orion, it had like, I think the hard disk tier was like 60% full. The flash tier was basically, has always been like 80 to 90% full, which is just not ideal. And when we creep up like past 85%, like we hit some weird issues where at that point, a lot of users are literally just better off like just only using a stripe against the hard disk tier. So not ideal to have this usage that high. And so anyways, I inherited Orion. And they're like, okay, here's Orion. It's kind of full. We should get some data off of it. And I was like, okay, cool. And my previous system was Alpine 2. It was a GPFS file system. I didn't have to worry about data management at all. It ran for like 8 months to get Summit 1 extra year. So it died before I even had to worry about deleting data. And I got not a single I.O. ticket ever. Like there was never a user that's like, oh, like, you know, what stripe do I use? And my I.O. isn't optimal. And then like the first like month I'm on Orion, it's like, just spammed with like I.O. tickets, like, oh, what striping do I need? Like, we're running out of space. So I was like, okay, like, let's run compression. Okay, we can't run compression because apparently in acceptance testing, we figured out that server side, we don't have enough CPU resources to run compression. So, okay, so we can't run compression. Okay, fine, we'll just purge it. And then they're like, well, we don't have a policy engine. I was like, what do you mean we don't have a policy engine? Like, we don't have a purge engine? So they're like, well, no, it's okay. We're developing one in-house. The technological integration team is like working on one. It's Polymer, we'll deploy it soon. Okay, cool, we'll have purge. We'll just keep, and yeah, long story short, basically like the past like 2 or 3 years, we just have to aggressively restripe data off the flash tier basically all the time. So we just got migrating data off in the meantime. So then we get Polymer set up, we go to deploy it. This is kind of how it's supposed to work. We have a 90-day purge policy. And so any files that are 90 days old are supposed to get purged. We run this on some utility nodes that are mounted to Orion. It's using a Nets message queue, which is part of Polymer's architecture. If you have Polymer questions, ask Rick about them. I guess there were some previous log talks about the architecture of Polymer. Anyways, in practice, so we purge like a test project before we go into production. Well, it's like in production, but it's a disabled like astrophysics project that's got like 50 petabytes of usage. We hit it with a purge pass and knocks off like 40 petabytes. We rejoice, we're happy, we're excited. We test like some other projects, it looks promising, we go into production. We purge Orion, we knock like 1 billion files off in like one pass. And then after that, it becomes apparent to us that there's kind of an interesting issue, or maybe not an issue, but a consideration where I guess like the way the Polymer works is when it's getting purge candidates, it does a lazy stat. And then before it purges something, it does like a full stat. And the lazy stat, the reason why we use that is because we were hoping to have like less metadata intense operations and then like hit the file right before we purge it with a full stat, just to kind of, yeah, save on metadata operations. And the timestamps don't match a lot, which is very interesting. We don't really know why. There's some scenarios up there for like when this happens. But fun fact, when we restripe our project, even if the file's like 90 days old, as soon as you restripe it, it changes the CTime info. So then now it's not eligible for purging. So then we kind of find ourselves in a catch-22 where we want to purge data and we need to migrate data, but we have to pick one over the other sometimes. Yeah, and usually subsequent passes will bring those timestamps in alignment. So sometimes to purge like a whole project, it takes like 2 passes. Sometimes it takes like 20. It depends. We've been looking into why that happens. We haven't really found a smoking gun yet. So eventually we got tired of this. So then we have a ton of these Orion routers. We have like 160 routers. I guess it was from when at one point Orion was very briefly mounted on Summit. So we had like 160 routers to like route, like LNet route Orion to Summit. And I heard it was actually a very rough time. I'm glad I wasn't there for that. But anyways, we end up just taking like 24 routers, threw Polymer on it, and now we're throwing that at Orion. So we kind of have like utility node Polymer, which just purges all the namespace. And then we use the router Polymer instances to like hit projects individually. Yeah. So let's see, what else we got here? Yes. So our current process for managing Orion. Now, if you notice the title of the presentation, it's Data Management Practices. We do not claim best, optimal, or ideal data management practices. This is just data management practices. So, say you get called and it's like, hey, your performance tier, the OSTs, they're over 85% usage. What do we do? So generally, we have this RATS web app that's developed in-house. It kind of tracks like users and projects and project activity. That's where the purge exemptions are listed. But it runs like a daily like quota, project quota thing, gives us a nice little fancy graph. So I'll check on Orion. I'll like look and see, okay, well, what projects in the last month have written a ton of data? Okay, maybe it's this project. And then, cross-compare that project to like a script we run across the performance OSTs that like ranks projects by like total usage on the performance OSTs. Sometimes we get lucky and those line up, and if you see a project on both, you're like, okay, like this person is probably doing I/O that's not shaping correctly, and they're filling up the flash tier. And sometimes they're on there, and you get some candidate files, you check the striping of the directories, and it turns out they are just doing I/O perfectly correctly. You just don't have flash tier space. And other times it's like very apparent, like, if you see a project, they have like 1,000 files, and the average file size is like 100 gigabytes, and it's on the flash tier, like that's very clearly like a file that should be on the capacity tier. So, yeah, we'll check utilization script, we'll find a project, and then we go in RATs, and it's like, well, since if we go to restart the project right away, if they happen to have old data that's 90 days older, we're not going to be able to purge it anymore. So then we'll hit it with like a ton of purge passes if they do have 90-day-old data until like the amount of data they have isn't really changing, and then we'll restripe it. So we'll use the manual Polymer run for that. And yeah, we'll check for restripe candidates directory stripe. So the issue with this, though, is that the latency for these operations is very long, kind of takes forever. So, and we have some improvements. So like we thought about just swapping Polymer over to a standard stat instead of using the lazy stat to just get rid of the timestamp mismatches and just eat the like extra like metadata load, I guess. And we've actually tried this on like 2 projects. And so Orion, like it has like 9 billion inodes, but like 3 projects on Orion, like each project has like 1 billion inodes. So there's some very large projects, and then you might ask yourself, well, why don't you just use quota? And my understanding from higher ups at OCF and management at NCCS, it's like there's a lot of users that actually really like to have a ton of data. Like the astrophysics projects, my understanding is that like there's, some projects where like if they wanted to, they could just fill all of Orion and still not get like the fidelity that they want in their data. So we tend to let users have as much as they want, which generally isn't an issue, assuming like PFL works. But also, as I mentioned earlier, the way that Orion was spec'd was presuming the OLCF4 sort of file distribution for Alpine. And I don't think it's probably any surprise to anyone. And I don't have data on this, we're working on it, but my hypothesis is that our workload has probably changed and is a lot more small file intense now, which probably isn't surprising to anybody. So I don't know that this conundrum is necessarily like a Lustre issue or like a Polymer issue. I think I think some of it's scale, some of it is the lazy stat that got us, some of it is, Orion is just big. It takes, hash directories on a billion inode project takes like a week or longer. So I think there's a lot of factors that are confounding here to make this kind of a, my professional word would be suboptimal experience. My personal word would be horrible experience. And so actually you can kind of see here, so we have, we like run Telegraph on Orion, and then Telegraph like shoots off data to like Kafka, and then it gets processed somewhere, and then we have a team member that like makes nice Grafana graphs for us, which is very nice. But this is like over the course of like less than a week, or about a week. And you can kind of see like usage like kind of steadily creeps, and where it's like flatlined is usually where like just standard Polymer that crawls the whole namespace is running. Like Polymer is very good at kind of holding usage in the same spot, which is good, but then the issue is like we're not decreasing usage, and then you can kind of see here it's like overnight basically between like April 13th and April 14th. It's like, oh, that's a runaway project. That just jumped, like flashed your usage up like 3%. And then that flat line where it remains high for the next like 2 or 3 days, that's like the time it takes for us to identify what project is it, check their directories, like see what stripe they have, like set new directory defaults. Because we've learned actually if you set directory defaults, if a user is using like code that has a library that just completely ignores PFL, like setting a directory default will just override that. So then we don't have to worry about like whatever they're using. But yeah, it takes, you know, yeah, you can see right there, it's like, takes us 2-3 days to figure that out. And then once we start migrating the project to the proper stripe, then usage drops like dramatically. But this is like 1 week, and this basically happens like every single week. So, yeah. And there was also some talk, we actually talked to James about this. We never did it, but there was like maybe a possibility that before we restriped something, we could like pull the old C time and then force it on the file after restriping it with, I think this is an ioctl or something like that. But it's kind of treacherous, and we didn't try that yet because it felt kind of dangerous to manually set timestamps. Yeah. So multi-tier storage is nice, PFL is nice. Sometimes it doesn't work. Well, it does work, but other stuff breaks it still. Orion's kind of massive, I think. You know, if any of you guys have like 9 billion inode systems, I can't imagine we're the only ones that do, especially with AI workloads and having a ton of small files. I imagine that's not rare, but like I said, this is probably suboptimal. So if you guys have any ideas and you're like, hey, don't do that, I don't know why you're doing it that way, feel free to let us know. But I'm very excited, like seeing yesterday some of the improvements, like I think in Lustre 2.17, the multi-threaded find, and then in 2.18, the Lustre find utility. Like that's very exciting. Maybe we can augment Polymer with that. Maybe we just use that. But I think some of that stuff will make our life a little bit easier. And yeah, maybe as a center, we need to figure out some different data policies for users. But that's kind of just an insight as to what it's like managing Orion. And yeah, thanks for the DOE for sending us here. Yeah, that's it. Any questions?
Okay, thank you very much, Ethan. 600 petabytes is a lot of data. Do we have questions?
One thing I thought of when you're talking about identifying projects, and you can use project IDs without a quota limit enforcement, just so that it's easier to find, you know, where the project usage is going. If you know, there's 4 billion project IDs, you can subdivide your development space, you know, in a hopefully find enough manner that you can just see the trends. Oh, this project is going up, and you know where to scan, as opposed to doing, you know, a full namespace crawl to see where the space is going. So that, you know, I think could help you, right? Just as a accounting rather than project quota enforcement.
Yeah, I could see that. I would probably remove this step of checking rats and looking at the.
Yeah. And I mean, the lazy statfs, you know, I know why it's like that, but it, you know, could probably be fixed fairly easily, right? The thing is that the lazy stat only gets updated if you're doing an open and a close on the client.
Okay.
And if you're just doing like stat on the path name, it's probably not sending any information back to the MDS that, you know, the client got the new size, and then it doesn't do anything to the MDS anymore when it just stats the path name. And so if the MDS gets an RPC for whatever reason, if you stat or you read or you do, well, not stat, but anything that does open and close, it will update the old timestamp, right? Or the lazy statfs time. So that could help you there, right? And you might consider not using C time as part of your purge policy, like A time and M time, right? And then just ignore C time, right? There's some argument whether migrate should change C time or not, but the feeling was that, you know, you're changing the file in some way, right? So there should be a record of that happening.
Yeah, I think that's a very logical, like, I don't know that it should be different, but yeah, it's like, when we realize that, it's like, oh, that makes sense.
Thanks.
Thank you.
Question about deleting data. I think you touched on that, but having deleted a lot of data previously, not in a Lustre system, that itself becomes a task of its own. It takes a really long time. So do you run into that situation where data is being deleted, but more data is being added, and deletions cannot just keep up because deletion itself are a action by themselves?
Yeah, so I think, if I understand correctly, like you can delete the file, but then the delete usually kind of lingers in the background. I think we've had enough space where we haven't really like hit the issue where maybe we run out of space. But I think looking at the graph, yeah, like Polymer, like it just scrapes just enough off, and then by the time like files get deleted and they're actually deleted, it's just enough to keep it in step with like what's currently being written for the most part. So we're kind of just always at steady state. Maybe some days we gain like a percentage or two less in the usage, but so I guess the answer to that would be no, not yet, at least.
Okay, all right, thank you.
Just to comment on the deletes, you can tune the object deletion rate. I can't remember the tunable off the top of my head, but I'm sure somebody in this room does. So anyway, point being, if your object deletes aren't keeping up, you can raise the limit.
I guess on that topic, I'll mention at Livermore, one thing we do is every kind of top-level directory has what we call an auto-delete directory file, and people can do a simple move of whole data set into that directory, and then in the background we have MPI file utils doing a parallel delete, and over 64, 128 processes or whatever, it removes them pretty fast. Any other questions? Okay. Thank you very much, Ethan.
Thank you.